Hello everyone, welcome back to your YouTube class on the topic pointers. So in the previous classes, we were knowing about your pointers. In the last session, I was dealing on pointer arithmetic, and we had also seen the list of different operations which we can perform on your pointers and the operation which we cannot perform on your pointers. So I will do a little bit revision on these points and then we'll move for the next topic. So the pointer arithmetics is some of the operators we can use in your pointer arithmetics. So the operators which we can use in your pointer arithmetic is the one is your increment operator. We can use is increment operator, that is the plus symbol, and the second one we can use is decrement operator, minus symbol, and the third one we can use is addition. We can perform the addition operation, so we can use the addition operator, and then we can also use the subtraction operation, that is the subtraction operator. So using these four operators, we can perform some of the operations on your pointers concept, right? So which are the operations we can perform on the pointers? That's a list we had seen. So the operations which we can perform on the pointers are, we can add some integer value to your pointer. The very first operation which we can perform on your pointer is, we can add some integer value to your pointer. So to add, we use this addition operator. To add some integer value on your pointer, we can use this addition value. Next, the second one we have is, we can subtract an integer value from a pointer. What you can do is, you can subtract an integer value from a pointer. Like what we can add? You can add integer value. Similarly, we can subtract that integer value from a pointer also. So to do subtraction, we can use the minus symbol or the subtraction operator. Next, coming to the third operation, we can compare two pointers if they point to the elements of the same array. Consider there are two pointers and both the pointers are assigning to the same array. In that condition, what we can do is, we can compare those two pointers. So the comparison of the pointers is possible. Coming to the fourth operation, we can subtract one pointer from the another pointer if both are pointing to the same array. So the subtraction of the two pointers is possible when both the pointers are assigning or are referring to the same array. Then that time the subtraction of two pointers is possible. Next, the last operation which we can perform on your pointers is, we can assign one pointer to another pointer provided both are same type. So if you are declared two pointers, one pointer value if you want to assign it to the another pointer, that is possible, but the condition is both pointers should be of same data type. If suppose you have taken one pointer as x, another pointer as y, and the value of x if you want to assign it to y, the value of x if you want to assign it to y, then what you can do is, that is possible, but both x and y should be of same data type. If x is int, then y should also be int. If x is float, then y also should be float. If x is char, then y should also be char. So both pointer variables should be of same data type. Then only it is possible to assign one pointer variable to another pointer variable. So these are all the operations which we can perform on your pointers. With this list, we had also seen the values or the operations which we cannot perform on the pointers. So which are those? The first one is, adding two pointers is not possible. Like what we subtract two pointers, and similarly addition of two pointer is not possible. The second one, the subtraction of two pointers is possible when both the pointers are referring to the same array. But when both the pointers are not referring to the same array, then that time the subtraction is not possible. That time the subtraction is not possible. Next, the multiplication of two pointers is not possible. Similarly, the division of two pointers is not possible. Just see what all is possible and what all is not possible. Adding an integer value to a pointer is possible. Subtracting an integer value from a pointer is possible. We can compare two pointers if both are referring to the same array. We can subtract one pointer from the another pointer if both are referring to a same array. And we can assign one pointer value to the another pointer when both are of same type. These all the operations are possible. Which all are not possible? Adding two pointer is not possible. Subtracting two pointers when both are pointing to the different array is not possible. Multiplying two pointer is not possible, and dividing two pointer is not possible. So these all the operations are not possible to perform on your pointers. Right? So after seeing the operations on your pointers, we have one example of the program. Okay, so let me write one programming example so that we can see how we can perform some operations on your programs. Right? So let me write first the program, then I'll trace the program. So we'll start a basic normal program I am writing. I'm not using any classes and objects here. I'm not using any classes and objects. We are just writing the simple program. Then so let me write first header files. So hash include iostream.h, hash include conio.h, hash include iomanip.h. So these are the header files which we needed to write your program. Next we'll begin with the main function. Void main, open the brace. Next, the variables which we need, first in the program, first we have to declare them. So the variables I need is int a, b, x, y. The variables I need is a, b, x and y. Next, the variables, pointer variables I declare them as star p1, star p2. I need two pointer variables. I declare them as star p1, star p2. That is asterisk p1 and asterisk p2. Next, I'll start writing the code for your program. Very first thing what I do is I want to assign some values to the variables. So let me assign the values to the variable. So a equals to 30. A equals to 30 and b is equals to 6 I am using. A equals to 30 and b equals to 6. So variables a and b are assigned with some values where 30 is assigned to a and 6 is assigned to b. Next, what I do, I use the pointers and I assign the addresses of a and b to the pointer variables. Then, so let me assign p1 is equals to address of a, p2 is equals to address of b. The two variables I had used, some values I had assigned to those variables, that is 30 is assigned to a, 6 is assigned to b. Similarly, the address of a is stored in p1 and the address of b is stored in p2. Done? So the assignment of your a, b and p1, p2 is over. Now let me perform some operations. So what I am writing is x is equals to star p1 plus star p2 minus 6 and semicolon. What I am writing, x is equals to star p1 plus star p2 minus 6. So perform this operation and store the value in x. Perform this operation and store the value in x. Next, coming to the next variable, y is equals to, what I am telling is asterisk p1 plus 6 asterisk p1 plus 6 divided by asterisk p2 plus 6. What I am doing, I am performing the operation asterisk p1 plus 6 divided by asterisk p2 plus 6. So the answer what you will get after this operation, that will be stored in your y. Done? So what x contains, the value after this operation, that is asterisk p1 plus asterisk p2 minus 6, and y contains asterisk p1 plus 6 divided by asterisk p2 plus 6. Then, so next I'll display the values now. So to display we have to write cout statement. Cout, the very first thing I am displaying is address of A. Address of A. So where address of A is stored? The address of A is stored in P1. So I'll display the value of P1 and L. Then the address A contains 30. If I say address of A and I display A, then 30 will be displayed. But what we want? We want the address of A. And where the address of A is there? The address of A is stored in P1. So what you have to tell is the address of A and you have to print the value of P1. Similarly, we'll see the address of B also. Cout address of B is equals to where address of B is stored? It is stored in P2. So P2 and L. Address of A is stored in P1. The address of B is stored in P2. So the address of A and B will be displayed now. Then next, now we'll print the value of A and B. We'll print the value of A and B. So for that reason, I'll write cout A is equals to the value of A. B is equals to the value of B and L. What I am doing? In one line, in one single line, I am printing both the values A and B. So the value of A is there in A, the value of B is there in B. Then next, cout similarly will print the value of X and Y. We print the value of X and Y. So X is equals to the value of X. Y is equals to the value of Y and L. Done? Now, we'll perform some more operations. What I do is asterisk P1 is equals to asterisk P1 plus 70. What I am saying? Asterisk P1 is equals to asterisk P1 plus 70. Next, asterisk P2 is equals to asterisk P2 asterisk P2 into 2 asterisk P2 into 2. So what I am performing here is asterisk P1 is equals to asterisk P1 plus 70 asterisk P2 is equals to asterisk P2 into 2. It is not asterisk 2, it is into 2. Here it is a pointer. This asterisk will consider as a pointer variable, but this asterisk is multiplication. Then don't get confused. After this, I will print what is this, how the operation is performed. I'll tell it in the tracing time. Then just now let me write the code first. Now I'll print the values. Cout, I am printing the value of A. A is equals to A. B is equals to B and L. Now I'll close the program, get ch and close the parenthesis. Close the brace. Then, so this is the code we have written. The program what we have written is on the illustration of the operations on your arrays. What all the operations we can perform on the array, or what all the operators we can use relating to your pointers. What all the operators we can use into your pointers. That point we are covering. Done? Sorry, it is not operations on array, it is the operations on the pointers. Done? So very first thing is I had declared the header files. So which all the header files we have declared? Hash include iostream.h, hash include conio.h, hash include iomanip.h. Next, the main function we had written, and then we had declared the variables a, b, x and y. Done. So I'll take here the array of memory. Then 1, 2, 3, 4, 5, 6. I'll take 6 only because 6 variables are there. Done. So this is A, this is B, this is X and this is Y. Now int asterisk P1 and asterisk P2 means this is P1, this is P2. Done. We had declared. Now let me write the memory addresses. So for this, I'll write as 1, 2, 3, 4, 5 and 6. We'll go for general. Normal examples we'll take. So all the 6 variables are declared, stored in the memory, and to them the memory location is assigned. Done. So this is AB, this is XY, this is P1 and P2. The memory location is 1, 2, 3, 4, 5 and 6. So in this way we had solved it. Done. Now next line, what is there? A equals to 30. So in A, what do you have to store? 30 you have to store. In A you have to store 30. Next, what we are saying? B is equals to 6. So in B, what you are storing? 6. In B, what we are storing is 6. Next, P1 is equals to ampersand of A. P1 is equals to ampersand of A means in P1 you store the address of A. So what is the address of A? 1. Actually it is a hexadecimal value, but for considering as it example we had written normally any values. Done. So P1 stores the address of A. Address of A is 1. The address of A is 1. Next, P2 stores the address of B. What is the address of B? It is 2. So in P2, 2 will be stored. Done. So till here it is we had traced. So in A1 30 is assigned, 30 is stored. To B 6 is assigned, 6 is stored. P1 is equals to ampersand of A we are telling, means address of A is stored in P1. The address of A is 1, that is stored in P1. In P2 address of B is stored, so address of B is 2, that is stored in your P2. Then next, coming to here, X is equals to what we are saying, asterisk of P1 plus asterisk of P2 minus 6. What we are telling, X is equals to asterisk of P1 plus asterisk of P2 minus 6. So what is asterisk of P1? Come to P1. What is there in your P1? 1 is there. What is 1? Memory address of A. Come here to the memory address. What is stored in that memory address? 30. You take that value. Asterisk P1 means go to P1, check which memory address is stored in P1, go to that particular memory address, and in that particular memory address what value is stored, you have to consider that value. So what is stored here? In 1, 30 is stored. So asterisk P1 means 30. Plus asterisk P2. Now go to P2. What is there? In P2, 2 is there. Go to this 2 memory address. Here what is stored in 2? 6 is stored. So take 6. Take 6. Now create the equation. This is nothing but 30 plus 6 minus 6. So what is 6 minus 6? 6 minus 6 is 0. So 30 plus 0 is 30. 30 plus 0 is 30. So what is X now? X is equals to 30. X is equals to 30. I'll repeat it. Understand? X is equals to what equation we have written? X asterisk P1 plus asterisk P2 minus 6 we had written. Asterisk P1 means, what is asterisk P1? We have to go to P1. In P1 what memory address is there? Check that memory address and go to that memory address, and in that memory address what value is written, that value you have to take it. So asterisk P1 means 30. Asterisk P1 means 30. So 30 we had written. Asterisk P2 means go to P2. What is there in P2? 2 memory address is there. Go to 2 memory address. What is there in that memory address? 6. So asterisk P2 value is 6. So the equation becomes 30 plus 6 minus 6. It will give you 30 as answer. Similarly, come here. Y is equals to asterisk P1 plus 6 divided by asterisk P2 plus 6 is written. So what is the asterisk P1? Go to P1. Memory address is 1. In 1, 30 is stored. So asterisk P1 is nothing but 30. Plus 6 divided by asterisk P2. What is there in P2? 2 memory address is there. Go to 2 memory address. What is there in memory address 2? 6. So 6 plus 6 is written. Now solve this equation. 30 plus 6 is 36. Divided by 6 plus 6 is 12. So 36 divided by 12. 12 ones are, 12 threes are. So answer of Y is equals to 3. Answer of Y is equals to 3. Done. Now we'll come to the Cout statement. We'll come to the Cout statements. So we'll display the output. Let me write here only. Output. What is first? Address of A. So what is address of A? It is stored in P1. So let me write first the message. Address of A. What is equals to? What is there in P1? In P1, 1 is there. 1 will be displayed. Next line, address of B. Address of B will be displayed. What is value we are printing? We are printing P2 value, that is 2. So why I'm saying address of A and I'm printing the value of P1. Why? Because the address of A is stored in P1, not in A. In A, 30 value is stored. If I say here A means 30 will be displayed, not the address of A. Done? So, for that reason, where the address of A is stored in P1, for that reason, I am printing the value of P1. Done? Next. Cout, next statement. A is equals to the value of A. What is there in A? 30. In A, 30 is there, so 30 will be printed. Next, B is equals to, what is there in your B? The value of B is there. So, what is the value of B? B contains 6, so 6 will be printed. Then, next line. Cout X is equals to. X is equals to. So, after performing this operation, what is the value of X? X value is 30. So, 30 is printed. Next, Y is equals to. After performing this operation, what is the Y value? Y value is 3. So, Y value we are printing, 3 will be printed. Then, after this, we are performing some more operations. Done. Now, come back. Asterisk P1 is equals to, what we are telling? Asterisk P1 plus 70. So, what is asterisk P1? Asterisk P1 means you have to go to P1. What is there in P1? P1 contains 1. Go to memory address of 1. What is there here? 30. 30 plus 70 is equals to, where it is stored in asterisk P1. Where it is stored in asterisk P1. So, what is asterisk P1? Asterisk P1 means, go to P1, 1 is there. So, asterisk P1 means A value. What do you mean by asterisk P1? When the term comes asterisk P1 means what we do? We'll go to P1, we'll check what memory address is there and we go to that particular memory address. So, in one memory address means we are going to A value. Now, what we are telling is the value which we'll get after adding 30 plus 70 is 100. This value we are storing where? In asterisk P1 means in memory address of 1 we are printing. That means A is assigned a now new value that is called as 100. Understand the statement once again. Asterisk P1 is equals to asterisk P1 plus 70 we are telling. What do you mean by asterisk P1 plus 70? Asterisk P1 means go to P1, check what memory location is there. Go to that memory location. In that memory location what value is there? 30 is there. Take that 30 plus 70 you do it. The answer will come 100 and store this answer in asterisk P1. Now go to asterisk P1 means as P1 one memory address, in this memory address you store 100 rather than 30. Done. So the new value of A is 30 now. Sorry, 100 now. Done. Next line is asterisk P2 is equals to asterisk P2. So what is the value of asterisk P2? Go to P2. In P2 2 memory address is there. Go to 2 memory address. What is there here? 6 is there. So take 6 into 2 is there. So the value is 12. 12 is stored in P2 now. Now again go to asterisk P2. 12 is stored in asterisk P2. So go to P2. 2 is there. Go to 2 memory location. Here you store the answer. What is the answer? It is 12. So 12 is stored here. Then so here 2 means B. So the new value of B is now 12 and the new value of A is 100. So when I am printing again one more time, A is equals to A and B is equals to B, rather than 30 and 6, it will print the new value 112. So here A is equals to 100 and B is equals to 12 will be printed. Clear? Like this program will be traced. So this program I had given you to know how your pointers can be operated, how you can use the different operators on your pointers value. Then, so this is a small example, programming example we had taken to just know how we can do the pointers, how we can perform the different operations on your pointers. Then, so the next most important point in your pointers is pointers and arrays. Pointers and arrays. So this question, pointers, arrays, has been asked for 3 marks, has been already asked 2 to 3 times for 3 marks. That is to explain the pointers of arrays, So today I'll cover the topic pointers and arrays. Okay. So there is a close relationship between your arrays and pointers. If you study C++, the pointers in your C++, there is a close relationship between your pointers and the arrays, because when all we are dealing with your pointers, I had told you the memory location and the addresses all are in the format of arrays, right? So always there is a close relation between your arrays and pointers if you are learning your C++ chapter. Done. So here we can consider the program, a small program where we try to print the elements of an array. A small program, it is not relating to the pointers, just I am telling how we can print the elements of a normal array. Done. So for that what we do is, we write first the header files, #include iostream.h, next void main, I am writing only one header file, open the brace. Then next I'll take the array int x of 5 is equals to, I assign the values here only. Done. So assign as 10, 20, 30, 40 and 50 because I had given the size as 5. Done. So I'll close it. Now I want to print the values. So what I do is, for int I, because I had not declared, int I equals to 0, from 0 till I less than 5 and I plus plus, you go on printing cout, that is the value of x, our array is x of I, and I'll take a tab space. Then get ch and close your array. So when you execute this program, what will be your output? Your output will be printed as 10, 20, 30, 40 and 50. Why? Because we had declared an array with the name x, size as 5 of integer type, and here only we had assigned the 5 elements 10, 20, 30, 40 and 50. I had not asked the user what is the size, enter the elements, like that. It is a waste. Just we want to compare the arrays and pointers. So I am just declaring the array and assigning the values. After assignment, I am printing the value. You know that to print the array values, we compulsorily need the loop. So as I has been not declared in declaration section, so I am declaring here int I equals to 5, I less than 5, I plus plus. Why 0 to 5? You know, because the subscript of arrays always starts from 0 and it is always 1 less than the size. Done. So int I equals to 0, I less than 5, I plus plus. So we are printing the value of x of I. So when I execute this part, I'll get the output as 10, 20, 30, 40 and 50. Done. So when we declare an array, its name is treated as a constant pointer to the first element of the array. When you declare your array, what happens here is that its name is treated as the pointer constant to the first element of the array. So this is also called as base address of the array. This is also called as base address of the array. What is called as base address of the array? When we declare an array, its name and its first element's position will be considered as the constant pointer, that is called as your base address of the array. So in other words, what we can just say that the base address of the first element in the array is, I'll take this one only, x of 0. This is the base address. This is the base address to the pointers. Done. So what we try to telling is that when you write a program, when the program needs to be access any element, when you write the program and the program want to access the elements of the array, the program needs to access the elements of the array. What happens there is, when you want to access, so we take the variables called as x of I. We take the variable called as x of I. See here, we have taken x of I. When I changes its value every time, like that the position changes, and what is there in that position, the value will be printed. So we take it like that. So it calculates its address. What it do is, it calculates its address by adding I units. So what happens here is, the elements of array can be referred to the program. Normally, how these elements are referred, like x of 0, x of 1, x of 2, x of 3, x of 4. In this way, the elements will be stored. Done. But when the program is compiled, the compiler does not save the address of all the elements. The compiler will not store the address of all the elements. Rather than, it only stores the address of first element. That is, x of 0 will be stored. This is x of 0 will be stored. And when the program need to access any element, then this x of I will be used and it calculates its addresses by adding I unit to the address of A of 0. For example, if you want to consider, what you do if you want to access the second element, so what it will do, in x of 0 plus 2 is added, so it will go to directly x of 2. We are not saying x of 2, we will just add the value, second value plus 2, first plus 1, third plus 3, fourth plus 5 plus 4. Like that, we just add the value of I. When we are dealing with the pointers. Then now, suppose it is of integer. So that 2 byte of the size for the integer will be stored. It will be stored relating to its particular data type. It is integer, so 2 byte will be stored. If you go to float, 4 byte of the data will be stored. And if you go to your char, the 1 byte of the memory location will be stored. In this way, the values will be accessed in the memory without using the subscript. It uses only the subscript of first variable, and how you want to access the elements based on this I position, it will go on adding the values. Then it will go on adding the normal values. Then now, if you want to see how the elements are printed or what is the relation between your pointers and arrays, then I write a small program code. I'll write a small, only the required program code, and we'll just compare it how in the memory it is worked. Then so let me write, we just see how we can print the elements of the array. So hash include iostream.h. we can add the extra, if you want you can add the extra header files. I'll just take the only one main function, and here int a of 5 I'm taking the array, and here only I'm assigning the values 10, 20, 30, 40 and 50. Then 5 size I had given, 5 values I had declared. Then now pointers, in a using pointers way, how we can print the values. So how we can print is cout. Asterisk of a. What I am telling, cout asterisk of a, some space value, tab space, cout. Now I am not taking asterisk of the subscript value. What I'll say, asterisk of a plus 1, asterisk of a, backslash of b. Next, cout asterisk of a plus 2, tab space. Next, cout asterisk of a plus 3. Next, cout asterisk of a plus 4 and a tab space, get ch and close it. Now we'll see how this program works. Okay, the program we have written, the normal code I had written, that is int of a of 5, array I had declared, and I had assigned the values 10, 20, 30, 40 and 50. Now what we are printing, it is relating to pointers. Cout asterisk of a, cout asterisk of a plus 1, cout asterisk of a plus 2, cout asterisk of a plus 3, cout asterisk of a plus 4 and one tab space of we are leaving. So the output, when you execute, output exactly it will print 10, 20, 30, 40 and 50 only. Done. But internally how it is worked, let me tell you. Done. So this one I am drawing here and I am explaining. So how it is there? There will be one table. I'll draw a table and I'll let you explain it, how it will be worked. Done. So first I'll tell you how manually it is worked. But only when we have the arrays, how it is worked, and when we are using the pointers relating to array, how it is worked, that we'll see. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10. So this is array. In a of 0, what is there? 10 is there. It is of integer, so I have to leave 2 byte of the area. So this is a of 1. Here 20 is there. A of 2. Here 30 is there. A of 3. Here 40 is there. And this is A of 4. Here 50 is there. Done? So we'll write here the memory location. The memory location is, we consider 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. Done. So when you are working manually, how it is created memory allocation in the memory is A of 0 contains 10, but it is of integer type, so 2 byte of the data is allocated, that is 1001 and 1002. Coming to A of 1, 20 it contains, 1003, 1004. A of 2, 30 is stored, 1005 and 1006. A of 3, 40 is stored, 1007 and 1008. A of 4, 50 is stored, 1009 and 1010 will be stored. Now, when you are dealing with pointers, when you are dealing with constant pointers, so your first element is considered as A, where A of 0 is stored. The address of A of 0 is stored. Now, next time we'll not call it like A of 1, A of 2, A of 3 and all. Only the array value, when we are using this for loop and the I value we are using, no, like that, how the I value is changed, the I value is added here. So here it is 1. For the first time it is 0, so A will be printed. For the second time it is like A plus 1. Here it is like A plus 2. Here it is like A plus 3. And here it is like A plus 4. So here A means A of 0. A plus 1 means A of 1. A plus 2 means A of 2. A plus 3 means A of 3. And A plus 4 means A of 4. In pointer constants, we are not referring to the subscript. In pointers, in relating to pointers, what we are doing is, we are only considering the first subscript, and next time when you want to access the next values, we are taking the I value, like here I value is 1, here I value is 2, here I value is 3 and here I value is 4. We are just adding those I value. We are adding those I value and then the values will be extracted. The values will be accessed. So here asterisk of A means what is there in of A of in the A position. So in A, asterisk of A, 1001 is there. What is there in 1001? 10 is there. Asterisk of A plus 1 means go to A plus asterisk A plus 1. What is stored in A plus 1? 1003 address will be stored. What is there in 1003? 20 value is stored. So 20 will be displayed. Next, coming to asterisk of A plus 2. So come to A plus 2. What is stored in A plus 2? 105 is stored. Now what is there in 105? 30 is there. So 30 is printed. Like this, your pointers array will be executed. Like this, your pointer array is executed. So here the expression asterisk of A plus 3 means nothing but A of 3. It is nothing but A of 3. So here the difference between your constant pointer and the pointer variable is the constant pointer cannot increment or change while the pointer to an array carries the address of the first element of the array may be incremented. So what we do is, as here every time when we execute, as here every time, see here, the normal array every time I value is incremented, then as I value is incremented, like that the subscript value is changed. But here when you are dealing with the pointers, here I value is not incremented. I value is not incremented. Rather than that, the first subscript what we have, that value we increment. That value we increment. Means first is A constant plus 1 changed. A constant plus 2 changed. A constant plus 3 changed. A constant plus 4 changed. So here when you are dealing with the pointers, the I value is not incremented. The first subscript is goes on the I value. Then here the exactly I value is changed. Then so this is how we work relating to your pointers. How we work relating to your pointers of the arrays. Then so it makes you confusion if I go to the next point. So I am stopping here only. The other points will cover in the next class. So in today's session we had covered pointers and the arrays. A small program I had written. The other exact program I'll write in the next class and I'll explain one more time. If you have any doubts relating to this, ask me. I'll clarify your doubts. Thank you.